Nice. Perfect.
Okay. Can we see we're good to go now?
Yep, perfect.
Okay. So basically, we're just going to give you a high-level overview of using Python at NERSC, talk about Conda modules, which Lippy mentioned previously, the NERSC Python module and its differences, as well as recommendations and best practices for creating environments and installing packages and other components on Perlmutter at NERSC. So using Python at NERSC. Well, basically to get started, all Python is by default available for users. You can load a specific Python module um, by doing a module load Python and then the type that's available. To launch Python, just like in any other terminal, you just enter the keyword Python to activate it. And it'll give you all of the useful information and whatnot that correlates to that specific instance of Python that's being used. So again, just a simple, easy introduction. So if you use Python anywhere else, it's pretty much the same process, but we use it through our module environments. And so let's get into more specific details on some best practices that we recommend for managing your Python environment. And that's specifically through using Conda. And Conda is basically just uh, a way for you to isolate your various programming environments so that it makes it easier for software projects and portability. So we have the Conda package manager that we use, and it's good for installing and resolving dependencies. Because when you work on a system like Perlmutter that has so many different hierarchical components and different libraries, the best way to ensure that perhaps a library that you need doesn't interfere with a system library is through a controlled, containerized, or package management environment. And so that's what Conda is able to do for us on Perlmutter. And again, it's very simple to activate Conda. You do your module load Conda, and then there's no need for you to do a Conda init or initializing it as well. Okay. And so the NERSC Python module is going to provide you um, access via the Conda environment. And so we have different use cases that we show how you can use it appropriately. But once you've done your module load Python, and then we have various Conda packages that are available, and you can easily just add those libraries to your environment. So this is just a abbreviated version showing you like some key Python libraries like matplotlib and numpy and scipy as well. Okay, and so some examples of how you can create your own custom Conda environment. And again, this is another way that the NERSC documentation is really, really great at providing details and, steps on how to accomplish this. But, we have simply here to create our custom Conda environment once we've done our module load Conda, and we do the Conda create command. And then we'll just have the -n, and what we're going to do is name our environment. In this case, it's called my environment. And we denoted the version of Python and other libraries that we want to have in this specific environment. You can make this, it could be my Fusion programming environment or whatever you want it to be. And then you just do a conda activate, and then my env is just the name of that environment that you decided to name it. Then once that's done, you're ready to load, and you can also use use Python from different containers and images, such as Shifter or Podman as well. And we use Shifter at NERSC for package management or container management for for Docker and Kubernetes as well. So that's another option for being able to use. One thing that you want to make sure when you say which Python in the terminal is that it is going to give you the system Python, which is not necessarily the Python that you're looking for. So that's another important thing to keep in mind, which is why it's important to understand and know how to use it appropriately through Conda environments. And so some tips from our experts here on using package installation management at NERSC is you want to make sure that you can either you install them via Conda or pip. That'll be perfectly fine, either approach that you take. And you can have access to different channels or more specific channels. You can have the access to different packages, such as the default package lists, or you can do specific channels like Conda Forge for a channel and a more detailed listing. And so you can also check the packages that you have installed in your environment by just doing a conda list command. So some other things to consider is that, we do have special wrappers that you can use for compiling various components as well. And so we'll get into that, such as MPI4Pi as well. And then we also have a specific module that you can use. The CUDA toolkit has various packages that can be used for to enable GPU computation if you're going to be doing a lot of work on the NVIDIA GPUs as well. So it's important to note that using that module will do a conflict with the default CUDA toolkit for those components. So you want to be specific with loading that. So one way segueing into how we can use MPI for Python, that's building a parallel version or Python application with MPI4Pi. You can use the Python interface, which is just going to be a wrapper to enable MPI computation. So MPI4Pi is available via the module load Python command. And then you can also specify specific involvements for that command as well with the once you do your conda create and you specify your environment. So in this case, you're specifying that it's going to be MPI4Pi, a GPU version, and you specify the version of Python you want to activate. And then you can also do a installation of the various, it's installed with CUDA toolkit. So it makes it pretty simple for you to containerize your programming environment. And in this case, it makes it very easy for you to do various force installs using pip as well for package management and installation. So one thing that we caution and advise about is making sure that users are just aware that the CUDAware MPI4Pi, you have to load the CUDA toolkit. So that's just another thing that people need to be aware of, because a lot of times you might get errors as to, not found, and it's because you haven't loaded the appropriate toolkit. Okay. Good on time. Okay. Another word of advice is just make sure you use pip with caution, because with pip it maintains a local package cache, but sometimes you don't necessarily want that. So we want users to make sure that their packages are using the user command are not confined to a particular environment. So you want to make sure with the pip install, you specify that specific package. So for example, if you want to install something to a specified base where other users can have access to it, then you want to specify that as well. So again, the best practices that we say is just making sure that you use pip install no cache directory and those specific flags, and then you are able to specify the package. All right. And so again, this can also tie back into a lot of the best practices for data management that Lippy just presented on. Running Python at scale at NERSC, if you're going to be running significantly large loads across multiple nodes on our system, we do have a few recommendations. Of course, use a container, shifter or podman. Try to make sure you specify your Conda environment appropriately. And some key things is avoid using your home directory, as Lippy mentioned as well, and avoid trying to run from CFS as well. Okay. So those are some best practices for, running at scale on Python with Python at NERSC. Some other common parallel Python pitfalls are making sure that you specify and understand if you're going to be using, MPI, OpenMP threads, specifying the number of processes and threads that you need to use, and making sure it doesn't exceed the physical CPU cores that you need as well. So by default, we have the worker. By default, in Python, applications will use like the CPU count for getting the number of processes, but that doesn't necessarily account for any CPU binding. So it's important to specify the number of workers you need to use as well. And then this is another opportunity where you could also use the our handy script generator as well that Lippy mentioned in navigating NERSC. And again, using Python at NERSC, just a high-level summary, of course, making sure you use Conda and containers appropriately. Make use of, for storage for your file systems or containers on our global file system. That helps for better performance. Make sure you use appropriate compiler wrappers. Avoid running with Conda init hard-coded as well, and be cautious of some of the pitfalls of using pip as well. All right. Did we have any questions about that portion of material? I just have about 4 or 5 more slides and then we'll be done. We're doing good in the chat?
All good.
Awesome. So using Python on GPUs. Using Python on GPUs, we have an array of resources that you can make use of. Important to note that NumPy and SciPy do not utilize GPUs out of the box, which is why we have other Python GPU-enabled frameworks that are able to provide essentially like drop-in replacements for being able to use those machine learning and other scientific frameworks at scale. So we can use that with CuPy and Rapids as well, that provide for support for NumPy, SciPy, and Pandas and other Python-heavy frameworks that use. And then we also have different machine learning libraries that do support GPU computing, PyTorch, TensorFlow, JAX, the ability to write your own GPU kernels using Numba and CUDA-Python as well. And then other different distributed memory libraries that are available as well, MPI, 4Pi, PlusX, Dask, and cuNumeric as well. So we have a number of different GPU libraries that you can use, and oftentimes we'll have various NUG community calls that are more targeted, 1 hour kind of lunch and learn community calls to kind of give you a bird's eye view of how to incorporate and how to use some of the different frameworks. So if that is of interest for you, always be on the lookout in our weekly email, as well as in for other targeted training emails as well. And so one thing that you want to make sure to make use of is with the CUDA toolkit dependency via our modules. And so you'll want to note that CUDA toolkit module is loaded by default, and it is going to be 11.7 once you've loaded in Conda. So you can always check to see how you can change that, or if you need a more specific version as well. And so with the Conda, with CuPy, we can do a Conda Forge. We'll pull the CUDA toolkit dependency into your Conda environment as well. And then you can just do your Conda create, name it whatever you want for this environment. And then you can also have CuPy Conda Forge package to pull that CUDA toolkit dependency into your environment as well through Conda install. Okay. Now, another thing that you want to also consider is understanding if your code, your application, or the algorithm you're working with is going to be suitable for GPUs, because not all parallelization is the same, and not all algorithms and applications will directly port. And so if you have application that typically is going to be a low latency application, then it's going to be ideal for CPUs. But if you have something that has a lots of computation, that has large arrays, matrices, or images, then if the data set can fit in GPU memory and IO is not a bottleneck, then GPU would be a great resource for porting your application. But it's important to consider that it doesn't always scale the same. So if you're not sure, again, as Rebecca mentioned earlier, you could book a 30-minute session with one of our experts that can best advise you on if your algorithm or your application would be portable for GPU versus using other approaches such as OpenMP or just MPI as well. All right, and wrapping things up, some best practices and where to get more Python information, as Lippy mentioned within our documentation. Our documentation is very robust and detailed, so that is always a great resource to easily find information. Of course, we have quick links here on different components. We'll go into detail a lot tomorrow on using Jupyter and running jobs as well at NERSC, and information again on how to submit a ticket. So again, if you ever get lost or confused, the easiest thing is just please reach out and submit a ticket. That's what we're here for. So, and that's also the best way to for us to see what user problems are occurring. So instead of just sitting on it, we often recommend that if you're struggling and it's not immediately available to you, just submit a ticket and reach out for help. All right. But again, thank you for attending today. Welcome to NERSC. We are here to help you and support you to make the best use of your allocation. It is a hard-earned allocation and a hard-earned process. So please be smart and reach out if you are ever stuck versus, continuously doing something. And, it's like Lippy mentioned, it's almost like money. Once your allocation runs out, it's gone, and you can maybe request for an increase, but that's not guaranteed. So be smart, make the best use of it. Reach out for help, read your weekly email, come to our trainings and also submit a ticket.
Great. Thank you so much.